Okay, so in this test portion 9F, we're going to discuss these three questions: class 9 science, chapter 9 force, and laws of motion, I think. So let's start with question 21, which is on page, all of them on 138. Okay, let me read the question. Two bodies have masses 3:4. So let's just right away assume, let M1, since they're in the ratio 3:4, first be 3x and the second mass be M2, 4x, following this proportion, right? Be the masses of the two bodies, or objects respectively. Okay, when a force is applied on the first body, so there is two cases. Let's take the case of the first body. Okay, for the first object or body. Okay, here let force applied, let F equal to, we don't know yet, is the force applied on the first body. Okay, then it moves with an acceleration of 6 meters per second square. Let F equal to force applied. Just let us put it here to move with an to produce an acceleration, let us say A1. Okay, A1, acceleration A1 equal to 6 meters per second square. So that's what the, so this, when this unknown force that is applied on the first body is being applied, it produces this much acceleration. The acceleration produced by the force is given, but we are asked to find the force, so we don't know yet. So how much acceleration with the same force? So let us write here, since by the second law of motion, the equation is this F will be the mass of the first body, because we are talking about the first body, M1, into acceleration produced in the first body, which is A1. So here this will be 3x into A1 is here 6 meters per second square. So 3 6 are, or you can just keep it like that. No, we don't need to bother to multiply anything. Even if you multiply, that's fine, but that's okay. Now second body, let us go. It's not hard, just proper understanding and applying it is important. So how much acceleration, just write in the format of the same thing, how much, like the question only. Sometimes it's easier to do. How much acceleration, let us say A2 for the second body, A2, A1 is for the first body. The same acceleration, the question is saying that the same acceleration means same force, not same acceleration. How much acceleration with the same force? The same force means F, as the same force means for the force applied on the first body is also exactly the same force applied on the second body. That's what it means. How much acceleration? The same force F will produce on the other body. Other body here means on the second body, which is of mass M2. So this is what we have to solve. How much acceleration? So we need to find A2. Again, since following the same second law equation, F2 will be equal to mass of the second body into acceleration F2, not F2 here, same force, so it will be F. F applied on first body is also the same F, same amount of force applied on second body, but second body has acceleration A2. So that implies this one here, F will be M2 is 4x, I think, here as you can see, into A2 we don't know here. We have to find the acceleration produced, that one. So that implies F has been already found in equation 1, 3x into 6 meter per second square. So replace the F, this one, by 3x into 6 meter per second square equal to this one, 4x into A2. So what is the acceleration produced by this same force on the second body is this one, A2. Don't move that. Then here 3x into 6 meter per second square divided by this 4x shifted will go to the denominator. So x and x cancel. 2 2s are 4, 2 3s are 6. So this will be 3 3s are 9 by 2 meter per second square is the acceleration A2. Therefore, acceleration produced on the second body will be 2 4s are 8, 1 in hand, 2 5s are 9, 4.5 meter per second square. So we will write if you want it, which is positive if you want to write like that, because it is coming out plus. Therefore, acceleration on the second body is 4.5 meter per second square. Positive means in the same direction as okay, that is enough. I think if you don't want to write, this is for this particular sum, the value of the acceleration is enough. They are just asking the value. Even if you write it's not wrong, you can stop here. The next here, these two questions we'll do in this class and 24 in the next class. Okay, so 22, let us go to question number 22. Let me read the question for us. A cardboard and its content has a total mass of 30 kg pushed across a rough floor. So let the cardboard with its contents, let us assume like this, which is not absolutely necessary, but it helps. Contents with this content be moving from left to right. So it is pushed from left side to the right side. Let us imagine like that. It helps us to understand better when we write the final answer. Okay, we're going to do what the answer is, minus or plus. So here mass M is equal to, together everything, cardboard and content is 30 kg. This is the mass of the object that we are discussing. Push across a rough floor at the rate of 0.8, or you can write like this. It helps. I think it's not wrong, but since in a cardboard, since the cardboard with its contents 30 kg in bracket are pushed, I'll shorten the statement, okay, at a steady rate of 0.8 meter per second, means initial velocity, because meter per second is the unit of velocity. Okay, then from here we can gather this information here. This is kg means mass, 30 kg is the mass of the object, and then steady rate means the velocity. So first appearance is the initial velocity, 0.8 meter per second. As we go on, when the box is no longer pushed, it comes to rest. So you just write here, since, okay, and it comes to rest. So this word is important. rest. R-E-S-T means no more moving, rest, in a distance of 0.5 meter, in a distance of 0.5 meter. That is, rest means final velocity v, is stop means 0 meter per second. Distance is denoted by s in our chapters. 0.5 meter is the distance moved across the floor. So what is the frictional force? So F question mark is the frictional force. Friction force or frictional force. We have to find F. Now let us do like this. You don't need to write this, just look here. We know to find friction force M into A. Most probably we'll use this. M is already there, 30 kg, as you can see here. But A is what we have to find out. Now in this one, V, U, and S is there. So if you want to find this F equal to M already there, A is the question mark. So here, 2AS is equal to V square minus S square. And the famous equation for motion in the motion chapter, right? 3 equations were there. So here, since, then I will write here A equal to V square minus, V square minus U square. U square divided by this 2S you shift, it will come down. Why? Because we did that because in this case we have V and U and S here. V is there, U and S is there. So we can easily find A. Once we get the A, we can put in this formula to find the friction force that we require. I hope you're getting what we're trying to do, right? So V is here, 0 meter per second, whole thing square, minus U is here, 0.8 meter per second, whole thing, bracket is a mass because this is squared, okay, divided by 2 into 0.5 meter, because S is, the box is pushed half meter, 0.5 means half. So 0 into 0, everything will become 0 here, so we can forget about there. Minus is there. Now here, 0.8 is 64, then 1, 2, so minus 0.64 you'll get, because it is squared. And this square power will come to the meter also, so meter square. Plus and minus, 2 ones are 2. So that's how we deal with the powers. Multiply the outside power to the inside, and that's how we do. Divided by here, 2 into 0.5 is 1 meter. Right, so 0.5 of anything becomes half, 2 will become half of itself. So meter gone here, 1 power, and here 2 minus 1 power still there. So you're getting minus 0.64 meter per second square. Equation number 1 you can put if you want. Therefore, friction force now M into A can be written as 30 kg into minus 0.64 meter per second square, and we can write here since using equation number 1. Right, so here we can get here now this to multiply this 0 you use, then the symbol will move here between 6 and 4, 6.4, no more 0. Multiply that to 3 is your answer. 3 4s are 12, 19, 1 decimal, so 19.2. Before that, multiply the sign, plus and the minus is minus 19.2, and kg here meter per second square, which is the best unit of force. So minus 19.2, in short we can write Newton. So we can write here which is negative. So the friction force is coming out negative. So this left to right is going to help us. So we can write your final answer. Therefore, frictional force or friction force, as the question is saying, F is 19.2 Newton, negative means in the direction opposite to the motion of the object. In this case, the object is the cardboard and its content. That is, from right side, friction is acting from right to left, because the box is moving from left to right. Minus means it is opposite to that original left to right. This left to right therefore helps us once we get plus or minus answer in the final step. So that is your answer. So this is your answer. This one is the beginning part, okay? That's it. We'll complete this 24 in the next class. So this 2 is done now. I hope you got it, right?